Alright, so for this video, we're going to be looking at how to integrate trig terms which we have not seen before. Okay, so some trig terms you can't integrate because there's no certain rules, which you looked at in video number 1. So in this case, what we have to do is use some identities that we've learned in the previous chapters to rearrange them or manipulate them so that they become trig terms which we can integrate. So for this video, you're going to need to know all the trig rules we've learned, such as the double angle formula, the compound angle formula, and also stuff like 1 plus tan squared is cos sec squared, stuff like this, okay? So I'm just going to go through a couple of these important ones which you should all be aware of. So first things first is how to integrate sine squared x. Okay, this is not in the form bracket, or we didn't learn this before, so what we have to do is now manipulate it to make it into a function which we can integrate. So you should always be thinking about what inequality, what identity can I be or use which has sine squared in it. Well, I know that identity sine squared x plus cos squared x is equal to 1. However, if I use this, I then have to be able to integrate cos squared x, which I also don't know how to do. So this is not going to be the identity that I'm going to be using. What I can use instead is the cos 2x, or the double angle formula, right? Because this is equal to 1 minus 2 sine squared x, which I can rearrange as sine squared x is equal to 1 minus cos 2x over 2. So this means that all I have to do now is integrate 1 minus cos 2x divided by 2. And we now can integrate cos 2x, right? So this would be 1 over 2x minus 1 over 4 sine 2x plus c. So as you can see, even though I couldn't integrate sine squared straight away, I manipulated it using a certain identity to make a trig term which I can integrate. Another example would be for if I was to integrate or asked to integrate tan squared. Let's go tan squared 4x. Okay, once again, I can't integrate this, but I need to think of an identity. Well, luckily, I know that 1 plus tan squared x is equal to sec squared x. And sec squared x is in the formula bracket, or we know how to integrate it from video number 1. So this one I can now replace as sec squared 4x minus 1 dx. And sec squared, when we differentiate or integrate that, it becomes tan x. So this will be 1 over 4 tan 4x minus x plus c, like this. All right, let's look at some more examples. Let's say I want to integrate now sine 4x cos 4x. This should be a fairly simple one, because what you should identify straight away is the angles are the same, right, instead of two trig terms, meaning that I can use the double angle formula, more specifically the sine 2a formula, because we know sine 2a is 2 sine a cos a. So this I can now replace as, our a is 4x, so therefore it's going to be sine 8x, and then there's no 2, so I should divide it by 2 as well. Once again, I can now integrate this, so this will now become sine goes to negative cos, so minus 1 over 16 cos 8x plus c. Okay, let's just try some more. So let's go for maybe tan x minus cot x to the power of 2. Okay, so it might seem difficult, but first things first, we should try and expand and see what we end up with. So this would give us tan squared x minus tan times cot is 1, right? So it's 2 plus cot squared x. We can't actually integrate to any of these, so we need to replace each one. Luckily for us, we looked at how to integrate tan squared before, right, in the previous one. So I can replace that straight away. So this is going to be sec squared x minus 1 minus 2. It's just now a matter of replacing this cot squared. Well, I know that 1 plus cot squared is equal to cosec squared, and I know that I can integrate cosec squared. So this now I can replace with plus cosec squared x minus 1 dx. So this will now be the integrating sec squared x. We have minus 4 plus cosec squared x. And so this will be tan x minus 4x, and this will give us negative cot x plus c. Okay, moving on. Let's say I have a similar question to this one here. Okay, sine 4x cos 4x. But rather than that, I'm going to write it as integrating sine 5x cos 4x. Okay, So as you can see, we can't use the similar method we used before because the two angles are now different. So therefore, we can't use the sine 2a equation. So this is a fairly difficult one. So what we're going to do now is actually use the compound angle formula. So it's going to be a sine cos. So I'm going to have to use I'm going to say sine 5x plus 4x, because I can now expand this, right? So this would be sine 5x, just using the compound angle formula, cos 4x plus cos 5x sine 4x. As you notice, we don't want this term here, right? We just want to be left with this term here. So I need to get rid of this term. So the way I will get rid of it is writing as sine 5x minus 4x. But it's the same combination, however, it's just now a negative sign here, like this. And so now what I can do is now add them together, sum them up, right? Because now I'll get sine 5x plus 4x plus sine 5x minus 4x on the left-hand side. Adding these two up means these two will cancel out, and you'll be left with two lots of sine 5x cos 4x. This sine 5x plus 4x is sine 9x, and we have plus sine x. But because we want to get rid of this 2 as well, I should divide it all by 2, so 1 over 2. So that means this original integral, I can rewrite it as 1 over 2 integrating sine 9x plus sine x, which is now simple for us to integrate, right? So this is going to be negative 1 over 18 cos 9x minus 1 over 2 cos x plus c. So if the angles are not the same, okay, then we can't use the double angle formula. You have to use a compound angle formula and try and make it using a certain combination of, it could be sine a plus b or cos a plus b, any one of those combinations. Let's just look at one last example. So let's say I want to integrate cos to the power of 4x dx. This might seem a bit difficult for you, but it's just looking at what we can integrate. So I'm going to rewrite this as cos squared x squared. The reason why I did this is because I know how to integrate cos squared x. I can use the double angle formula, more specifically the cos 2a one, in the cos squared form. So 2 cos squared a minus 1. So cos squared a would be equal to cos 2a plus 1 divided by 2. So this here, I'm going to rewrite it as a is x in this case. So it's going to be cos 2x plus 1 divided by 2. And this is all squared like this. Now I can just expand the bracket. So 1 over 2 squared is 1 over 4. So I'm going to bring that outside. And now I'm going to get cos squared 2x plus 2 cos 2x plus 1. I know how to integrate cos 2x. I know how to integrate 1. It's just a matter of integrating cos squared 2x. But I can use the same form here, right? Where a is now 2x. Okay, so this will now be 4x. So this will now be 1 over 4 integrating cos 4x plus 1 over 2 plus 2 cos 2x plus 1 dx. Now it's just a matter of simplifying before integrating. So we're going to get integrating 1 over 8 cos 4x plus 1 over 2 plus 1 is 3 over 2 plus 3 over 8 plus 1 over 2 cos 2x dx. Now we've got this, we just have to integrate, right? Cos goes to sine, so it's going to be 1 over 32 sine 4x plus 3 over 8x plus 1 over 4 sine 4x like this. Sorry, 2x, sorry, plus c. So as you can see, all these trig terms is all about remembering the certain identity to manipulate it to a certain trig terms that we do know how to integrate. Once again, this integration just takes a lot of practice and repetition. You need to go through a lot of questions and just be familiar with certain steps, or just be familiar with certain patterns that you do recognize.